To summarize some of your key findings from the investigation, we found that the second difference of the y values in the table of values are constant if the x values increase at a constant rate, and that's true for our quadratics. We also know that we can decide the direction of opening based on the sign of those second differences. So based on the sign of the second differences, if that sign is positive, we know second difference. If it's positive, we know that the parabola is going to be concave up. It's an opening up parabola. If the second differences are negative, it's going to be concave down. And that, of course, is provided that our values of x are increasing at a constant rate. Now, our axis of symmetry is that equation of the vertical line, so it's always x equals a number, and that number will always match up with the x-coordinate of the vertex. So if we had a vertex of h comma k, like I've written here, if that's the vertex of your parabola, the equation for your axis of symmetry will always be x equals h, whatever the x-coordinate of the vertex is, because your parabola is going to pass through, your axis of symmetry will pass through that vertex, and the vertical line is x equals whatever that coordinate is. All right, your maximum and minimum value, which is also known as your optimal value that we talked about the day before, will always be equal to the k-coordinate of the vertex. So if your parabola is opening down, like it is down here, we know we have a maximum. We're going up, 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 reaching a high point and coming back down again. So that reaches a maximum, and its maximum value will match up with whatever the whatever the k-coordinate of the vertex is, whatever that y-coordinate is. If your parabola opens up, you reach a minimum and then go back up again, but your optimal value will be a minimum of whatever the k value is. All right, our domain and range. So those are brand new, spanking new today. Domain are whatever values that x takes on in the graph. And because with parabolas, because they keep going out in both directions, they go out this way with the x values as we head up, our x values keep heading out this way, and as we go up on the other side, our x values keep heading towards the negative. And same when we open down. As we go down, 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 our x's are just continuing to go in both directions. So in the end, the domain, if we don't have context for our parabola or for our question, if we don't have a domain, let me just erase that stuff. If we don't have, a context, then in general, just in general, the domain will always be any real number. So you could use the words any real number, so x is any real number, or the math symbols that represent this are x. This is a Greek letter, it's the epsilon. X is an element of, so this means is an element of, or it also means belongs to the set, is an element of. And then this capital R, we can't do boldface, or I can't do boldface when I'm writing very easily. So I just do a double line on my stem of my R, this double line right here. And that stands for the real number system. And the real numbers are any number you can possibly think of. So it's all fractions, all decimals, all whole numbers, all negatives, all positives, repeating decimals, non-repeating, non-terminating decimals, any single number at all you can think of. It's going to cover it all. Once we look at applications, so we started this unit with applications, and we talked about like the rocket being launched, the soccer ball being kicked, or we can talk about a ball being thrown off the roof of a building. We don't want to look at the entire parabola. Like this segment here is meaningless, because if this is time, time really doesn't make sense to be negative in this value or in this context. Likewise, these values of time over here don't make sense because we can't have negative heights. So we would do what we call restricting the domain just to be the values from here, which would be 0, up to the point where this rocket hits the ground or the ball hits the ground or whatever it happens to be. So whatever that value is, we're going to limit what our domain is. With range, the same things can happen with range in terms of limiting it, but in general, it's still going to depend on where the vertex is and the direction of opening. So it also will depend on applications, but but more importantly, even before we get to applications, it's going to depend on where that vertex is and the direction of opening. So in my above example, if my highest y value ended up being 40, let's just say for an easy number, the highest the ball reached or the rocket reached was 40 meters above the ground, then my y value is any real number, except we're going to limit it that y would have to be less than or equal to 40 in this case for the rocket. So it was opening down, so my y's all get smaller than or equal to 40. If it was a parabola that was opening up, so I'm going to switch that around. I've got a parabola that's opening up. Let's say the vertex ended up being here at -5, down here at -5 for the y-coordinate. It's still any real number because I'm not leaving any values out, except that y would be greater than or equal to -5. Okay, and we put those in curly brackets because the curly brackets means the set of y belonging to the real numbers, and the comma in math means and y is less than or equal to 40. This isn't a huge part. I wouldn't worry about the notation here. If you could describe it in words, that is super awesome. If you get to the notation, that's okay too. But that's more of a grade 11 focus. The 3U and 3M, we focus on domain and range in both those courses. So hopefully you understand. If you have questions, make sure you're asking.